compositions of functions. So we still didn't get a chance to talk about the domain very much. So number 3, it says find the domain of f of g of x. So if I'm finding f of g of x, I can write it with a little o, or I can write it with parentheses. That's why it's of. So f of g of x. So we're finding f of 1 over x to the 6th. So we take the 1 over x to the 6th, and we replace our x value with 1 over x to the 6th. So it's going to be a little messy. So we're going to have 1 over x to the 6th, and it's going to be raised to the 2/3. So that 2/3 power is going to go up to the 1. So I'm going to have 1 to the 2/3, which is still just 1. But I'm also going to have x to the 6th to the 2/3. So I'm going to have 1 over x to the 6th to the 2/3. What do I get when I do x to the 6th raised to the 2/3? Any ideas? X to the multiplier powers, 12 over 3, right? So 4. Do you guys see it? Because you're going to have like 6 over 1 raised to the 2 over 3. So you multiply 6 over 1 times 2/3 and get 12 over 3, which is 4. So we're going to have 1 over x to the 4th. Okay, so when we talk about the domain of a composition, we need to consider the inside function. So which function was the inside function, as I'm calling it, when I talk about f of g of x? G of x, right? What was the domain of the inside function? So of g of x, what's the only thing I couldn't have for x? 0. And I also think about the final answer. Now in this case, I have 1 over x to the 4th. It still can't be 0, right? So our domain is still just everything except for 0. So we're going to say negative infinity to 0, union 0 to infinity. So that's one way of writing the domain. Or if you want to be kind of lazy, which I encourage, it's okay, write it the easiest way possible. X is not equal to 0, so you can write it that way as well. Okay, so this next one, so part B. So we're still finding f of g of x. So our inside function is the g of x function. Let's think about the domain of our g of x function. Okay, it's a little tricky. Do you guys know what critical values we have? So what's like our turning points? What are the critical values of 9 minus x squared? 3 and negative 3, right? So we're going to put both of those on a number line. And think about what we can have and what we can't have. Can we plug in 0? Is that okay? 9 minus 0 under square root? Yeah, that works. Can I plug in 4? No, 9 minus 16 is a negative number, right? And can I plug in negative 4? No, same thing. 9 minus 16 is a negative number. So the ends of this don't work. So our domain is everything that's on the inside, and it does include the 3 and the negative 3 and 3. So we're going to keep that in the back of our mind. So our original domain, we couldn't have anything on the outsides of 3 and negative 3. All right, so I'm going to do f of g of x, though. So I'm going to take my g of x function, and I'm going to plug it in for x right here. So do you guys see what's going to happen? So that square root of 9 minus x squared is squared. So we get 2 over 9 minus x squared. Okay, and the domain of this final one is just that x can't be two numbers. What two numbers can we not have there? 3 and negative 3. So we have to put this together for our final domain. So we have to say everything in that original inside function we can't have. Like anything that was not in the domain originally can't be in the domain now. Okay, but we also need to consider the final one as well, where we said, oh, but x can't be 3 or negative 3 as well. So look at our original number line. We're just erasing the negative 3 and 3, because now they can't work. So now our final domain, instead of being bracket negative 3 to 3, it's actually going to be parenthesis negative 3 to 3 for that domain. Yeah?
X can be 0, fx equal 2 over x squared, so
yeah, like this part can't be 0. So you can say 9 minus x squared equals 0. So x equals plus or minus 3 when you solve that.
on top of the
Oh, like here, right here?
Yeah.
The f of x we don't worry about. It's the inside function that we worry about. So let's test. So Bill's asking a good question. He's like, well, what about x equals 0? Because that domain, for the f of x function, it didn't look like you could have 0, right? What if I found f of g of 0? Let's see if that's okay. So let's start from the inside. G of 0, what's G of 0? 3, right? So then I'm finding f of 3. Is it okay to find f of 3? 2 over 9, right? That works. We got an answer out. Does that make sense? So when you have those compositions, we don't really worry about the outer function because that's like manipulated along the way, and that worked out okay there, right? So what he was asking is he was saying, well, x can't be 0 because that first function. But it could because we were doing one big composition. So it was getting changed along the way before we got to that. All right, so number 2. So find two functions f and g such that f of g of x is equal to h of x. There are many correct answers. Okay, so here's the key to these. So we ask these questions in pre-calc. We actually ask a very similar question in calculus when we get to something called the chain rule. Are you girls paying attention back there? All right, here's the thing. When we're writing something as like f of g of x, we're worried about an inside function. Okay, so what I want you to do is look at this and tell me what's on the inside. So for part A, what's on the inside? 1 minus x. So I didn't even have to say inside of the parentheses or anything. You guys got that the inside was 1 minus x. Does that make sense? So if I let my inside function, g of x, be 1 minus x, and I said f of x, well, what function am I plugging 1 minus x into? What am I replacing the x with? X cubed. Do you guys see that? Then that works out. So you can do like your f of g of x, and you can check it. So if I'm checking f of g of x, I have f of 1 minus x, which goes into the f function that I made of x cubed, so I get 1 minus x cubed. That's how that works. So there are several answers you have. You could do like really weird things. I don't know. I don't know what you want to do. That's the easiest way to do it. So on the next one, can you identify like an inside?
X plus 2.
Yeah, you could do like x plus 2, right? So we're going to let inside be our g of x function, and we're just going to make it x plus 2. So what function am I plugging that g of x into? 1 over x, exactly. You guys got it. Does that make sense? So what do we think on the next one?
X squared plus 3.
Yeah, x squared plus 3. And we're plugging it into the outer function of square root of x. Make sense? Easy. All right, so let's stop there and then we'll do our inverse.